Right, our discussion is beginning right now, and I've just noted the time is 13 past 10. And here is our first example of the day. And our first example of the day goes as follows. Find is an example. Right, example 1. Find the area bounded by the curve. Right. Y equals x squared minus 6x plus 5. Okay, begin with something easy, and then we build to more complex questions. X's in the lines, right, in the lines. X equals 1 and x equals 3. Okay, let's focus on this particular example here and see how this example can be solved. Find the area bounded by the curve y equals x squared minus 6x plus 5. The x-axis in the lines x equals 1, x equals 3. Okay, now we shall prepare a solution to this very quickly. This one is very straightforward, so we're not gonna waste a lot of time there on this, but we shall just make sure that it is a very clear example. Right, the solution. So to actually write the solution, first we write down the defining equations. And x equals 3. We need to write down the defining equations and quickly we need to graph these. Okay, always we need to graph these. Because if we do not graph these, then obviously we might not be able to see the area we need to compute. And so how do we draw the graph of these? Now, this is very, very easy. First, we need the usual stuff. X-intercepts. And to get the x-intercepts, we let y be identically 0, which means x squared minus 6x plus 5 is 0. Equals 0, the factors of x squared are x and x. We have minus 5 minus 1. We have x equals 5, or we have x equals 1. Okay, these are the x-intercepts. All right, these x-intercepts, a couple of things are important. So x is 5, y is 0, x is 1, y is 0. Next, what else do we need? We need what we call the y-intercepts. It's only one for the parabola, and is obtained when x is 0. Y is x squared minus 6x plus 5, which means it is x squared minus 6 plus 5. And this y-intercept occurs at a point where x is 0 and y is 5. Okay, very easy stuff. Then now we have the x-intercept, so the last thing we need to do is the vertex. Right, the vertex is obtained at a point where x equals minus b on twice a, which is minus. Here is the b is minus 6 over twice a, which is 3. And so now at this point, x equals 3. Y, not the squared, but just y, So y is x squared minus 6x plus 5. Okay, there's a formula you can use for the parabola, but you can just substitute the x coordinate of the vertex and be able to see that this is 9 minus 18 plus 5 is 14 minus 18, which is minus 4. Right, so the vertex, right, the vertex is given a 3 minus 4, like so. Okay, so we have everything, and we can just quickly draw a sketch of the graph, like so. What did you get the x-intercepts to be? We got them to be exactly 1 and 5. The vertex is at 3. Right, so we got them to be exactly at 1 and 5, the x-intercept. So the y-intercept is obtained at 5, y equals 5. At y equals 5, if this is the y-axis, so now this one here, where x is 3, y is minus 4. Right, so at this point, x is 3 and y is minus 4. It's the vertex. Right, so x is 3, sort of midway, because it's 2 units this side, 2 units that side. So yeah, okay. Now this is what we have. But yeah, we read further. This is not the only information, because they've told us a couple of things, that it's an area bounded by the curve. This the x-axis, and the lines x equals 1 and x equals 3. Okay, so the x-axis bounded by the curve, the x-axis, x equals 1 and x equals 3. So x equals 1 and x equals 3. The curve, the x-axis, x equals 1 and x equals 3. So that is the region that is wanted. Okay, now if it is the region that is wanted, we ask the question, what is the area? And what is indeed the area here? So now we're able to see that the area is given by area. Right, so now the area, obviously this is the x-axis, is actually performed, we're going to do integration with respect to x, but between 1 and 3 on the x-axis. Right, and what we do here is we project an arrow straight into the region vertically upwards, and that is the strategy. We project an arrow right through the region straight up like so, and you're able to see the bottom curve and the upper curve, and then you're able to say most certainly at this point that a projection through the region will actually get into the region at the bottom and exit at the top, meaning the upper curve is given by what? Right, the upper curve is given by the y value here. What is the y value there? 0 minus the y. So we say the upper curve minus the lower curve. Okay, so upper curve. Okay, it's the upper curve minus lower curve. So the area. What is the upper curve? 0.
0.
The lower curve. Okay, with respect to x.
4.
Yes. Okay, the upper curve is this, and what is the lower curve? It's x squared, right? X squared minus 6x plus that. Okay, so the upper curve is y equal to 0 and the lower curve is exactly that with respect to x. Okay, the lower curve is the whole parabola there between 1 and 3. Okay, the area is what we want. We integrate from 1 to 3 and we distribute with the minus, getting x squared plus 6x minus 5. And the result can be determined with ease. So, and this basically means the area. It's the integral from 1 to 3. We have seen that is minus x squared plus 6x minus 5 and with respect to x. So then the area. Okay, so now if we perform this integral here, it's going to be x cubed over 3 plus 6x squared out of 2 minus 5x, and this is performed from 1 to 3, like so. And what is then the answer to this? So you have the area. You plug in the 3. So it becomes minus 3 cubed out of 3 plus 6 into 3 squared out of 2 minus 5 into 3 minus, right, we plug in the 1. So it becomes 1 cubed out of 3 plus 6 into 1 squared out of 2 minus 5 into 1, like so. And what is then the area? Okay. So, okay, 3 cubed is 27 divided by 3 is actually a 9. So this is a minus 9. Divide 6 by 2, you get a 3. Right, so 3 by the 9 is going to be 27 minus 15. And then this is going to be plus 1/3. And this is going to be minus 3. This is going to be plus 5. So, which means the area. Okay, what is minus 9 plus 27? It's exactly 9.
18.
Right.
18.
Yeah, it's exactly 18. Good. Right. 18 minus 15 is what? It's a 3. Minus 3, 0. 5 and 1/3. Yeah, that's the answer. 5 and 1/3 square units. Square units. So that is the answer. So this is the area that's wanted. Okay, so we got the correct answer. And now we're just noting the method there. And this method is the method we're going to use. Okay, let's look at another example too. An example. Okay. Find the area. Bounded by the curve y equals x squared minus 3x minus 2x minus 3. Okay, I'm going to do lots of examples. The x-axis and the lines. Right, and the lines. X equals minus 2. So let's look at the solution to this. What is the solution to this? Find the area bounded by the curve y equals x squared minus 2x minus 3, the x-axis, and the lines x equals minus 2 and minus 4. So now, what then is the answer to this question? Okay, very straightforward. And we just quickly can do this. Now, first things first, we need to just find the x-intercepts. What are the x-intercepts? So they occur at where y is 0, which means we have x squared minus twice x minus 3 equals 0. Okay. And then now this here is exactly what? It's exactly x squared minus 2x minus 3 equals 0, which means you have x with x, and we have minus 3 and 1. And this is 3, or x is minus 1. So now this is exactly at the point where x is exactly 3 and 0, minus 1 and 0. Okay, so these are the x-intercepts. And then it remains to quickly find the y-intercept. How do we find the y-intercept? We let x be 0. So at that point, we have x squared minus 2x minus 3. But when x is 0, it means we have 0 squared minus 2 by 0 minus 3. And the result is 0. Meaning the y-intercept is at a point where x is minus 3. Is minus 3. All right. So we agree that at this point, it's going to be minus 3, meaning at the point where x is 0 and y is minus 3, we have our x-intercept of our y-intercept, rather. Okay, the next thing we're going to do now is to deal with the vertex, because this is a parabola. Right, the vertex of a parabola is found at a point where we have minus b over 2a. Okay, minus x squared. Just writing the function at the bottom here. So we have actually minus x squared, like this, minus, rather x squared, plus x squared, minus 2x minus 3. Okay, that's what we have. Minus twice x minus 3. Okay, that is what exactly we have. So we plug in here. So it's going to be minus. The 2 is minus 2 over 2 into 1. Which is 2 over 2, which is 1. Okay, so which means you have y equals 1 squared minus 2 into 1 minus 3, and this is minus 4, which means at this point x is 1 and y is minus 4. Okay, right. So at this point, we have found everything, so we can sketch. Right, so let's look at the sketch quickly, and the sketch is done as follows: y together with x. Right, y together with x. So now what then do we achieve from this? Okay, well, at what point, what are the x-intercepts? Minus 1, 3? Right, minus 1, 3. And then at this point, you have 1 minus 4. Right, so you have 1 minus 4, and that is the vertex. And what about the y-intercept? Minus 3. So it's going to cut at minus 3. Oops. Okay. Right. Just a drawing. Just drawing quickly. Like so. There's a vertex here. And then it's minus 1, 3. And then it's going to cut here like so. All right. And let's revert to the question, because this is the graph of x squared minus 2x minus 3. But now let's look at a couple of things that sort of underpin this. In terms of the okay, further boundaries. Okay, right. The area is bounded by the curve, this, the x-axis, and the lines minus 2, 4. Minus 2 and 4. Okay, the lines minus 2. So in other words, minus 2 is here. Right, so there's going to be a line here. And 4. Like this. And yes, minus 2, 4, the x-axis as well. And obviously that means you also have this one. Right, so obviously the x-axis, the curve, the x-axis, and the lines. Okay, so this is sort of the area that the examiner wants. So now we're going to have 3 pieces of the area. Area 1, area 2, area 3. So in other words, the area, right, is going to be the same as, right, first we integrate from minus 2 to minus 1. We perform integration from minus 2 to minus 1. And then we focus on the upper curve. The upper curve is, okay, yeah, if you imagine a projection, an arrow that goes through the region, it will enter the region through this point. And then when I say the upper curve, what is the upper curve? The upper curve is the parabola x squared minus that. So it is x squared minus twice x minus 3 minus the lower curve 0 dx. And then here between minus 3 and minus 1 and 3. Okay, so we're going to add this one. Between minus 1 and 3, what is the upper curve? Upper
It's
curve is
0.
this one 0 minus the lower curve x squared minus 2x minus 3. And then from 3 to 4. And then now you have, at this point, if you imagine an arrow that goes through the region, the upper curve is going to be the parabola and minus the lower curve, the x-axis. Okay, so which means you have x squared minus 2x minus 3 minus the x-axis, which is the same as y equals 0, meaning the area. Right, so if you integrate these, then we have x cubed out of 3. Okay, so this one is going to be minus 2x squared out of 2 minus 3x. And then here you have minus x cubed out of 3 plus 2x squared out of 2 plus 3x. X cubed out of 3 minus 2x squared out of 2 minus 3x. 3 to 4. Area. Okay. We have this exactly, and we just need to substitute everything. Okay. It's minus 1 to the 3rd power. It's a bit more terms here. Okay, minus 2 cancels out. And it gives us minus 1 squared. Minus 3 into minus 1. minus 2 cubed out of 3 minus 2 squared minus 3 into minus 2 and then you put minus 3 cubed out of 3 okay, a bit more terms here. All right, so we come to this one here. And then we be plugging in the 3 there. Right, there's a plus, check. Then you have minus, is minus 3 cubed? Let's see.
Yeah.
Yes. It's exactly plus 3, but there's a...
yeah, yes. The minus
yes,
makes it
yeah,
negative.
there's just a minus in front. Okay, yeah.
Yeah, yeah.
All right, thank you. Right, so there's a minus in front and it's just 3.
Sorry, the minus must be outside of the, yes.
Oh, yes, of the brackets, yeah.
Yeah.
Like so, good. Let me just write clearly there. Like so, okay?
Yes.
Good. Let's see now, what is the next one? Okay, then here the 2 cancels out, leading to a 3 squared. So just plus a 3 squared.
Sorry, sir.
Next.
Stay on that page. Go to the next page quickly.
Okay, yeah. All right, so 2 cancels. And then here, plug in the 3, so it's going to be 3 by 3. Can write a 9 if we wish.
Okay, just check there. You said minus 3 cubed on 2. It must be on 3.
Let me check. Well done, well done, well done. Well done. Right, it's on 3. Thank you, you're so right. It's on 3. The next thing. All right, okay, just to have a bit more terms in this particular problem. Then we just plug in, substitute a minus 1 then. So it's minus. Okay, everything else is the same. So it's minus, and you put minus 1 u cube out of 3. Minus 1 u square. 3 into minus 1, like so. Okay, because it's the upper limit substitution minus the lower limit substitution. Next. What else is missing? The last part. Okay, the last part is exactly the same, but we're plugging in 4. So which means, okay, let me see. We're plugging in 4, but yeah, the signs are the opposites of the top signs. Yeah. So that's just one observation. So the signs are the opposite. So you plug in 4 cubed out of 3 minus 4 squared plus minus. Okay. All right. Minus 3, then 4. Like this. So we've plugged in 4 there. Okay, we'll continue. We are here, please. We are going on. I'm just loading more terms. This is quite chunky. Okay, we're here. Plugged in the 4 and with the minus sign. Let's see. Right, so it looks okay. Minus, we plug in the lower limit of integration, 3. 3 cubed out of 3. 3 squared. 3. All right. We'll need a calculator here to help.
My calculator doesn't take all that units.
I get your point. Okay, I think that it will just to avoid a couple of errors. Okay, I'm gonna load a calculator just to make sure that, because now we'll just be dealing with these fractions and whatnot, and Okay, just a sec. My calculator will load quickly. All right, here's the calculator. Okay, because we have a couple of fractions and there's always a chance of human error here. And audience want us to make mistakes and to waste a lot of time saying this is this is that, then this not use the calculator quickly. Okay, now, okay, first let's just do this here. So to do those, a couple of ways to do that. So we can do this and then put this fraction. Okay, let me just do the comp, make it computational. Right, so if I put the open parenthesis here and you do this, and then now you're going to have like -1. You close and then you cube. Okay, right, so, and then 3. Right, and then here you put a minus here, and then you put another -1. You square it like so. Okay, and then there is -3 into a -1, and then you close here, minus open parenthesis, fraction, -2, and you close and you cube it, and then 3, and then -2, and you close, and you square, -3, and you do -2, and you close. Okay, so we've done the 2. What's the result? Okay, so the calculator is giving us 7 out of 3. Right. Okay. Right, so what we're getting, it's 7 out of 3. Right, we're getting exactly 7 out of 3. Okay, we're gonna do the others quickly, please. Right, so I'm trying to avoid a couple of mistakes here. So we got 7 out of 3 from the previous 2 expressions, and then now we just need to do these ones quickly. Right, so in doing those, so let's load our calculator. Then let's see what we have here. Okay, that's fine. Okay, now let's do on button and okay, good. Fraction. Then we can start and say like -27 quickly, and then 3, and then 9 plus, and then plus another 9 from the 3 by 3. Then you subtract. Then here, this one here is going to be exactly 1/3. And this one is going to be +1. Plus, okay, at this point, okay, this is 4 cubed, obviously not a 43, it's 4 cubed. And that one is a 64. So in other words, we can just quickly put here, can even put it as 4 cubed, it's okay. Right, and then you divide by 3, and then that's a -16 4 squared quickly. And then this one is a -12, and then you close. Minus, then here you're going to do a 9 out of 3. and then it's going to be -9, and then -9. Like so. Okay, you're close. Okay, this is 1, 9. 19. Okay, gonna check this, but yeah, it looks correct. Right, so it looks like it is exactly a 19. Right, so meaning that this one is exactly a +19. Then what is the result of this here? Right. Uh-huh. Okay. Right, so what is the answer here? It looks like there might be a small error. Either we made an error or...
The first one is the first two is 11 on 3 is what I get, not 7 on 3.
Is it? Okay. All right, I'll check that quickly. Okay, let me just go back. Here you got 11 out of 3 here.
Yeah.
When you did all this here.
Yes, all of that.
Okay, let's see. Okay, quickly.
So I got
what about...
the first one is 11 on 3, and then the second part where you go -2. Yes, from there you get -22 on 3. So those two gets you -11 on 3.
Okay, let me just check quickly. Okay, what did you get here? 11 on 3, was it?
Yeah.
And then this one, what did you
minus
get it to be?
22 on 3.
Is it 22 on 3 minus like this or anything, or minus here?
Yes.
Okay. Right. So, okay, yeah, it might be right. So, wondering how then what sign error was made in actually on the calculator, but yeah, it looks like it's going to work out. Let me see, because just too many terms. So now, which means that if you have this pointer is going to be -11, because 11 minus 22 is -11.
Yeah.
It appears, therefore, that this here is going to be -11 on 3. Okay, so -11 on 3 plus 19. Okay, 3 goes, times into 11. Right, it goes 3 times. It goes 3 times, remainder what? Remainder 2 on 3, because it divides 9, plus 19. Let me see. So still it's not. Okay, because I'm expecting 15 out of 15 and 1/3. Okay, so I'll have to check this. Okay, we'll have to check this, because it doesn't come to this. Because if I accept that, it provided the textbook did not make a mistake here. Okay, because I'm looking at the textbook. Okay, now at this point, then you'd have 19 minus 3. What is 19 minus 3? It's 16, right? Let me see, just one sec. Okay, it might be right. It might be right. Just 1 minute. Just 1 minute. Let's just, yeah, this minus 2 and 1/3, but it might just subtract from that, giving that. Might just be correct. Let me just see quickly. Uh-huh. It might just be right. So this one here is going to be 3. So divide 3 by 3 is -11 by 19 by 3. Okay. It might just be correct. Let's just check quickly. Right. What is 19 by 3 minus 11? I'm just checking that one. 19 by 3 minus 11. 46. What is 46 divided by 3? It becomes 15 and 1/3. Yeah, that's the correct answer. Okay, that's awesome. I'm glad, because then we're look for mistakes. They're not going to look for lots of mistakes. Okay, that's excellent stuff. So it means, therefore, the area required. The area is 15 1/3 square units.
Yes.
Right, so it is exactly minus 11/3 there. And it is exactly like so here, 11/3 minus that. Yeah, so it is fine. It is super correct. Excellent stuff. Okay, right, so we look at the next question.
Sorry, sir, I have a question. If you can just
Yes,
go back
please.
to the first page.
Previous?
So let's say, yeah, previous
Yes.
page. Let's say the question was between the x equals -2
Yes.
and minus 1. So let's say if you go to the only the
The other
first
one.
part, yeah, they're at the bottom. No, they're at the bottom.
Okay. Okay. And
No. Go one
another
forward.
one.
Go forward. Okay, another one. Yeah, there. If you look at the left units there on the draw, no, the sketch that you made.
Okay, you want the sketch, eh?
Yes. Okay. Yeah. Okay.
Okay.
The left one there, -2 till, yes, that part. So if you
Yes.
work out, you get negative units. Why would that be?
Okay, if you work out and get negative units,
Yes.
obviously it means that you need to take the absolute value, because area is positive.
Yes.
But the negative units actually in mathematics indicate that you did not compute your area correctly because the area must be positive.
Okay. So go to the next. If you go to the next page, then.
Okay, the next page, yeah.
Yeah. Okay, right at the bottom there where it says area, that
Yes,
first
area,
part. Yeah. So that first part is in other words, is the area
Yeah,
there, isn't it?
yeah, because this first part is the one from -2 to -1.
Yeah. So that's
And
that
yeah,
area that we
and
are speaking of.
yes, which is
Okay. So that part
the
where the pen is
leftmost
now.
area.
Yes.
Uh-huh.
Yes. So where the pen is now is the most left area.
Yes.
Okay, but you get 11/3 minus 22/3, which makes it
Which
minus
is
11/3.
negative. Which is negative.
Yes.
Right.
So that's why I'm asking,
Obviously,
why is it
well,
negative then?
at this point, what I can say is it's because it's part of the overall computation, but in the end, the total area desired is what? Is positive. Because the total area, so a part, so yeah, the total area required is positive. So all is well if this happens, you know. But I hear you there. In the event that such a thing happens, what do you know, the thing I want to mention here, because there is potential confusion about the positive and negative areas and so on. And I can see the way the study guide is also doing the work. It's covering this work. The study guide itself has a tendency of getting negative areas and then putting in absolute values around them, you know.
Okay, so if I
And
get a negative value, I can just say, no, it's positive. I can just write down it's 11/3 units and not mention the negative
well,
sign then.
because at this point, 11/3 minus 20/3 is minus 11/3.
Yeah.
But for the method we are using here, because we're doing it from first principles, we got minus 11/3. And therefore, if this is the only area, then
Yeah.
you must say the area is therefore 11/3 is the positive result. But if it's part
Okay.
of
Okay.
if it's part of a
Yeah.
long calculation,
Yeah,
then you
don't
must
switch the sign. Yeah, if we switch the sign there, you're gonna make a big
a mistake.
thing. Yeah.
Yes.
Yeah.
Yeah. If one switches the sign here, then we're not gonna get the same answer, but it's gonna be wrong.
Yeah.
If somebody takes the positive here as part of the overall calculation. So my advice is one, is that with the way we are doing it, what approach, what formula are we using? We're using the upper curve minus lower curve approach, because in mathematics, if we say the upper curve minus the lower curve in graphical terms, we assume that the y value here is larger minus the y value at a lower position. So that if you then say the upper curve minus the lower curve, the expectation is a positive result in that sense. To say, if somebody
Yes.
travels distances, here's a person traveling a distance, and you say at this point is 2 kilometers, and they traveled a further distance of 5 kilometers. How do you get the amount of the distance the person traveled, for example? Well, in mathematics, if this is the horizontal axis, the x-axis, well, we just say 5 minus 2,
Yeah.
because the expectation is that if you then say the larger value minus the smaller one, we expect a positive result. So in area terms, it's the same. And hence, if you use that approach, the absolute value can only be applied at the end of the calculation. If ever the area was to be negative here, which I never expect using our approach, the provided, I mean, the question would have said, find the area only here, you know?
Yeah.
Suppose if they'd said, find the area only between -2 and -1, and don't find the area here, but find the area over here, obviously one would have found a negative result, no doubt, because you've been integrating from actually -2 to -1. Okay, so if you're integrating from -2 to -1, because -2 is smaller, so you're integrating from a smaller limit of integration to a larger limit of integration, but also you then say the upper curve, right? The upper curve is this, is the parabola.
Yeah.
That's
Yeah.
what it's above. And the lower curve here, because you always say y is increasing when you go upwards. That's why all the arrows we use to study this, we study things from bottom up. So,
Yeah.
which
Yeah.
means that now you say the upper curve. You take the parabola minus the lower boundary, which is the x-axis. So, which is what we did here. We then said the upper curve is the parabola minus the x-axis, the lower boundary. Okay, we did that. And obviously, if these were not there, all of them, so and would have had this, and would have had that, and would have had up to here.
Exactly that. Yeah.
Would the area have been positive or negative? Well, it would have been negative here.
Yes.
Okay, that's a very interesting observation. But then in the end, you would then say the area is positive, but you had
Okay.
followed the fundamental principles of mathematics and the measurement of
Yes.
distance and areas to say you take the largest minus the smallest, and the expectation is a positive value. But obviously here there is a reason why it is actually negative. There's a mathematical reason, in which case you can't
Mm.
force it except to then say if the area desired is only this, then, and your final answer would, if it was a negative answer, you would have to conclude therefore that the area is positive. Okay, and obviously the examiner would understand the kind of approach you're using, because it's thinking for reasoning from first principles to say, find the distance between 2 and 5. Okay, you take the final position minus the previous position, you know. That is
Mm.
how we do it in mathematics. That's how we do it in mathematics calculus books, okay, because this is calculus, and this is studied in calculus books like your Stewart and the books you find there in mathematics measure students who do calculus. That is the approach that is used to, we say, the upper curve minus the lower curve. And now we don't just apply absolute values like intermediately. I'd not like the approach by the study guide, because the study guide has their own approach, and they assumed things are easy by just looking at the x-axis and the graphs all the time, and to say you can just always just integrate the function. Just integrate the function from whatever x value to whatever x value. If the answer is negative, you take you take the absolute value of that. But in mathematics, that is not okay. By mathematics, I mean by using standard uh, principles in calculus. Calculus that is found in the Stewart textbook. That's the big volume of, and the Thomas and Finney and many others. So we reason like that. It's a pity that over the people who read the study guide here sometimes had their own way of reasoning, absolute values all the time. But I wouldn't say apply intermediate absolute values, because that's going to create confusion. If only we use upper curve minus the lower curve approach. Okay, let's look at the next example. Right, we look at an example. Right, so now looking at this example here, example 3. Okay, this one is an easy one. They've drawn the graph for us and they're asking us to find the area. And the question goes as follows. Find the shaded area. Find a shaded area below. And we have that. Y-axis, x-axis. Like so. And then now if you have like so. Okay, there's a some strip here. And then now y is x to the 4th power. All right. X to the 4th power. Right. All right, if it's x to the 4th power, then how do you find the area here? Okay, we need to find the shaded area. Okay, but what are the numbers? Okay, it's 2 here. It's 2 here. Okay, we continue. Right, it's 2 here, and then is what? It's 1. Like this. Okay, so we need to just find the shaded area, and it's very, very straightforward. Let's find this area. Right, so let's look at the solution to this. Right, look at the solution to these. We proceed as follows. Okay, now, the principle is the same, but now you need to reason and see which one is easier. If it's easier to calculate the area when you're going upwards or downwards. So you reason in 2 directions. Okay, we don't go diagonally. We only go upwards like this or horizontally like this. So let's see now. What is this? What is the area? So now we're going to find the area here. Right, clearly projecting and viewing the region from the bottom up is problematic because we don't know the X values here. We can't see any markings, so it's going to be technical for us, but it's possible with a lot of work. The easiest is to look at the Y values and realize that Y is from 1 to 2. And then if we look at the region horizontally, we use the same approach, upper curve. Right, we use the same approach, upper curve minus the lower curve. Okay, by using this approach, we know in mathematics that the upper curve minus the lower curve approach, as said already, is not really that reinventing the wheel here. We mathematicians and mathematics major graduates and researchers, we look at when we study regions, we look at the upper curve minus the lower curve, and then now we then say these are y limits of integration, and therefore it's dy. Okay, next, the area. So that we have the area. Okay, it's still 1 to 2. Next, we continue. Okay, we continue. So it means that Okay. The upper curve minus the lower curve. So which one is it's the upper one when you are actually viewing the region horizontally from left to right. You can see that the upper curve is this graph here, whose equation is this. So it is x to the fourth power. Right, so the upper one, the furthermost, will be x to the fourth power minus the other y. So it's y is this here, but what is y there?
0.
Okay, so, right, so, yeah, that is the thing. But yeah, I want to mention something important, just 1 sec. Right, because obviously, okay, you need two functions of y here. You need functions of y as much as obvious that. So you'd need two functions of y. So ideally, you'd need an f of y. Need to just elaborate on this. You'd need an f of y minus a g of y, excuse me, minus a g of y, like so. dy, area, from 1 to 2. What is f of y? Okay, here you'll need a function of y, but you can see that it is exactly of this form, so you need to manipulate it a little bit for it to work, because you must integrate with respect to y. So in other words, you have that y is x to the fourth power, which means, which is like this. So which means it is y minus, okay? So this is a function of y. And then now you need another one. The question is, x is equal to what? X is equal to what here? Clearly x is 0. Right, so clearly x is 0 on the y-axis. So the lower curve is the x equal to 0 because x equal to 0 on the y-axis. So, well, we do it like this. This is the correct approach. Okay, right, now the area. Okay, now let's do this. What is the area here? So now you're going to add 1, which is 5 out of 4. 4 out of 5. Okay, so you add 1 to this and it becomes 5 out of 4, and then 4 out of 5. 1 to 2. 4 out of 5. 2 to the 5, 5 out of 4. Okay, right. 5 out of 4 minus 4 out of 5, 1. 5 out of 4. All right, 4 out of 5. So this is 2, 5 out of 4 minus 1. Okay, so this is the answer. Okay, anyhow. There's nothing to do. Right, there's nothing else to do, so okay. Can write like this and say, can you find the decimally equivalent of this? So approximately 1.03 units squared. Okay, so that is the area. Next question. Right, so the next question is another example. Right, this example says find the area enclosed by the curves. You find the area enclosed by the curves. y equals 1 plus 1 over 5 x squared and y equals x squared. Solution. Right. Let's look at this. Find the area enclosed by the curves, this. Okay, these are very, very simple curves, very easy, okay? In mathematics, a simple curve, a curve is simple if it does not cross itself. So they can always, you can have simple closed curves, etc. Okay. So let's just try to understand these. Okay, these are like grade 10 graphs. Okay, we learned these at grade 10. Right, so why? Right, at grade 10, we are taught, therefore, that the graph of y equals x squared, that is the first parabola we learn at school, right, when we're still in high school. And it is like this. It actually sits at the origin. Okay, from grade 11, we begin learning the translated hyperbola graphs. So you have y equals this, 1 over 5x squared. Okay, the other one is the same kind of graph, but it is having a coefficient 1 over 5, meaning it's open. This one is narrower, the x squared graph, but this one, because of the fraction like that, is wide open. But the 1 means that the graph is translated 1 unit up, meaning it's going to be cutting at 1 here. Because when x is 0, right, we can see that when x is 0 here, when x is 0, y becomes 1. Can put it here. So like this. Okay. Now, what do we need here? We need to find the area enclosed by the curves. The question becomes, which one is easier? To look at it horizontally or to look at the region vertically? Okay, it's easier that the vertical one is the vertical one is the easiest one, because now one can do either way. I mean, you can do it either way. You can, so we're going to actually integrate from bottom up. Right, so if we integrate from bottom up, right, so we're going to fix the x-axis, and now we're interested in knowing exactly the point of intersection here and the other point of intersection there. So the next thing is to find the points of intersection. Points of intersection. Which is 1 plus 1 over 5x squared. So now if you have these, x squared minus that is 4 to 5. X squared equals 1, which means x squared equals what? Is equal to 5 out of 4. And this means, okay, is plus or minus the square root of 5 out of 4, and this is plus or minus So then what is the area? Okay. So, okay, yeah, it's easier to note those. Okay, we can continue with either of them, but yeah, in mathematics, we prefer accurate values, or we're going to prefer the accurate ones. So, meaning that we're going to have like the minus the square root of 5. So, yeah, I mean, you can also write these as plus or minus the square root of 5 out of 2. Okay, because square root of 4 in the bottom is 2. So, meaning that, okay, you're going to come here and say it's minus the square root of 5 out of 2, and then you put the plus here. Okay, so yeah, we saw it. So the area, we start integrating from minus the square root of 5 out of 2. Okay, we start integrating from minus the square root of 5 out of 2 to plus the square root of 5 out of 2. Right, to the square root of 5 out of 2. What is the upper curve and what is the lower curve if you study the region from bottom up? Right, so the upper one is clearly this one, which is just 1 unit above the standard x squared parabola, meaning it's 1 plus 1 over 5 x squared. So it's 1 plus 1 over 5 x squared minus the bottom graph is the x squared graph dx. Okay, so yeah, we sorted and we're able to get the answer here. And it's very, very easy. So the area. So which means you have the integral from, okay. Right, we have the integral from minus the square root of 5 out of 2. Okay, and then here is minus 4 to 5 x squared dx. Okay. So what is the answer? Right, if you integrate the x, the 1 is x. You integrate this one is 4 to 5. And then integrate this one, which is going to be exactly the cube. So it's x cubed out of 3. We integrate from minus 5 out of 2 to the square root of 5 out of 2. So the area. So now you plug in wherever there is x, you put the square root of 5 out of 2. Minus 4 to 5. Okay. Can you put a 15 here? Yes. Okay, just 1 sec. Because now you have the 3 by 5 in the bottom here and write it as 15, 1, 5. So this 3 by 5, we can put it as 15, and then we put the square root of 5 out of 2, cube it. The square root of 5 out of 2, cube it. So minus the square root of 5 out of 2. So this one is minus the square root of 5 out of 2. like this. Okay, oh, okay, this one is also minus. Okay, this is also minus in the place of the x. Let me see what I put here. Okay, yeah, it's minus. We put minus. Okay, right. So this one is going to be a bit more work by hand, but the calculator, don't know why there was a typo at some point using the calculator, but it's a bit more reliable. It's more reliable, so I'm going to pop it up again. Just going to check. Just going to check, obviously, if the answer we're getting is okay. Right?
Why is it a minus
Let's come again.
inside the brackets? Why does it
Okay, let
become a
me check.
minus inside the bracket here?
Yeah, this, okay, that's a question. Why the minus? Okay, obviously it's because of the fact that there's a minus here. Let's just check that because you need to get correct answers. Let's check this part here. Loading. Right. Okay, I want us to check this part. Just bring that up. Okay, we're here. That's what I wanted to say. Right, so you know, if you plot the minus,
No,
the
not there,
minus
not
root of
there.
5 out of 2, here it's going to be minus, there it's all going to be minus.
It's 1 minus something. Why does it become the 1 minus? It's supposed to be a plus if you look there at the top, isn't it?
Okay, become okay. All right. Because something very important to note is that first we substitute the square root of 5 out of 2 here in the place of x. So we put a square root of 5 out of 2, and we put it here as well. And then minus, we always say the upper limit minus the lower limit. So minus everything. So minus all these chunk here, but in the place of x, we then put the minus the square root of 5 out of 2 in the place of the x. Okay, let's just see what you
Okay.
get.
All right. Yes. Okay. I get it.
Let's just see what you get. Just one sec. I'm going to use a calculator because you can get a very nice compact answer here with the calculator. But even by hand, one can. But the problem with the hand calculation is it might take some time, but there's always a chance of human error. Let me see. Okay, good. Oh, fraction is there. Okay, I'll have to try and make sure we watch here to type the correct stuff. Okay, because now to make sure that we get the correct answer. So you have the square root of 5 out of 2. Then there's a minus. Then there is 4 out of 5. Okay. Then square root. And then okay, then you raise it to cube. And then you close. Okay, so then you have 4 out of 5. 4 out of 15. Ugh, did I put a 15 here? Uh-huh. Okay. Here. Okay. Should have been a 15 here. Um Okay, see, a small error like a 15 here would have made the answer. But yeah, I mean, I have the final answer anyhow. So I'm just going to check if getting the same answer as the textbook or not. So you have this one here. So you're 15. And then you have minus here. And then you have this minus square root. Right, square root of 5. And then you have 2. And then you close. And then now you do this. You cube. And then, yeah, you have this. What is the answer? Okay, it appears that this is the answer. Let me see. Right, it is 2 the square root of 5 out of 3. Let's check. I'm going to write it down. Right, what we're getting from the calculator is actually exactly 2 the square root of 5 out of 3. Right, or it is exactly this. 2 the square root of 5 out of 3, which is 2 the square root of 5 out of 3 units squared. Okay, I need to check if this is the sort of answer they got. Just a minute, because they used some approximations here. Okay.
Approximately 1.5.
Yes, approximately 1.5.
Yeah.
So I'm trying to see if it is approximately 1.5 as well, because it might be, it might not be. Yeah. So 1.49. Okay, because in the textbook they just did some decimals, which is okay. Approximately 1.49. So okay, obviously there is a discrepancy between our education system in South Africa and the world, because we are using the same decimal point as some countries like Brazil, because now the British and the Americans use a decimal point, which I prefer because I believe it's more international in the well, in America and in England. The British system and the American system use the decimal point. So that here we write 1.49 in the American system and the British. But obviously, I discovered that some countries like us here in South Africa and Brazil, and potentially others, use a decimal comma to actually show decimals. So yeah, but I prefer a point. But I mean, one can use a comma as well. But in the international setting, the Americans and the British, they do not understand a decimal comma is something else. In America, if you write this, is written like this to mean a million, you know, to mean a million, but we use a decimal comma to mean a decimal fraction. So we can adopt these kinds of presentations, but I believe that they become quite ambiguous with our own number system, etc. Okay, it's just a comment. Next example. Right, in the next example now, we're going to look at the loop. How do we deal with loops? An example. Find the area of the loop of the curve y squared between x equal to -1 and x equal to 1. Okay, let's deal with the loop. How do we deal with this loop here? Okay, find the area of the loop of the curve, this one between x equal to -1 and that. Let's look at the solution to this. Right. First things first, we need to sketch this. So let's sketch the loop. Right. So to sketch this loop, there are a couple of things you need to consider. So you need to consider that you have y squared equals x squared into x plus 1. Y squared in that. Which means y is the same as the square root of x squared into x plus 1, like this. Okay, so we have this. Now, what then is the meaning of all this here? Well, okay, this is not is a technical question, so not very examinable. It can take you some time to analyze this, but you'll have the loop here. And then you have the loop here. Okay, but yeah, there's plus and minus here. So that you'd have at the point that you take the square root, you'd have plus or minus, and then y equals plus or minus, like so. Now, okay, find the area of the loop between x equal to -1 and x equal to. So let's find the x-intercepts of this. Right. Because it's not a usual curve. Okay, so in the end, which is this? So you have this. Okay, so it means therefore that you'd have 0, 0 is going to be twice, x equal to -1, y equal to 0. Those are the x-intercepts, meaning you'd have 1 and 0 here. Okay, so the origin here. So between x equal to -1 and x equal to 1, so x is -1 here, and then there's x equal to 1 there. Okay. Mhm. Right. So there are many ways to do this particular question. For example, right. So looking at this question, you can do it in two ways because of the nature of this particular question. Okay, we are continuing, please. We're analyzing this carefully. So it has certain ramifications for the analysis of this. What is the square root of x squared? Right, you can find the square root of x squared. Well, I must indicate first and foremost that the square root of x squared itself has two signs. So if you have y equals plus or minus the square root of x squared into x plus 1, in mathematics, the square root of x squared is the absolute value of x. So you have that. All right. Okay. Okay, this question has a small error in the question. So I need to adjust the question. There's a small mistake in the question. And this mistake was carried forward in the textbook. Okay. In the wording of the question, it should be that, just to make things easier for us, it should be that between -1 and 0. Okay, but yeah, one can go beyond that. But okay, in the textbook, they made a typo there because they actually have considered up to 1, but that was not even the case at all. So, okay, there are a couple of ways, obviously, to look at this, and you shall just use one method, and then the rest we'll discuss them. For example, one can decide to look at the symmetry can decide to look at the symmetry. So if you integrate like from -1 to 0, and then you stick here to this, then you can multiply that by 2 to find the other area, which we shall use. So you just find the area of one part. Okay, how else can you draw this graph? To draw this graph, because it's not a parabola, this. One way to draw this graph is to just use points, point by point plotting, and realize that it is a loop like this. Okay, because doesn't follow, it's not a parabola, so you can't just find the vertex and the x-intercepts and then say you're done. Okay, right. So, but now we're gonna then find the area as follows. Area. So the area we're gonna find is from -1 to 0. But if we study the region, like we've said, between these and these, which one is the upper curve? Okay, I always draw an arrow there. So the upper curve becomes the graph, but which part of the graph will that be? It will be the upper part of the graph. So if the graph is drawn like this, basically, it means that the upper part is the positive part. So you can write it like so. X plus 1. Okay. And then the bottom part is going to be the negative. So you can choose which one to study. So you have, okay, so you integrate these from -1 to 0. Then the upper curve is this, and the lower curve. Okay, yeah, the upper curve is this, and the lower curve is this one, which is y equals 0. Okay, like this. Now we have this, and we just need to find one segment, and then we shall multiply this by 2, like so. Okay, so which means the area we want, because that loop is symmetrical. So which means it is 2 we have this. Okay, we just need to find the integral of these. And then we have learned integration, using integration by parts. All right, using integration by parts. So now integration by parts uses the formula u dv is uv minus the integral of v du. So what is the answer? So now at this point, you need to integrate and then differentiate. Now choose which one has a derivative that's gonna be a number. So it's easier to let u to be x, and then dv to be, so this is u dv, so u is x, and then dv is everything else. Comparing this with the u dv, all right, which is x plus 1 dx. What is the u? So it's 2 over 3, which is 3 over 2. Okay, this one you can easily integrate because okay, so we have u v, the integral of v du. Okay, so which means that we shall have this one, which is x. Okay, I just left the limits of integration out, and then we'll just multiply by 2, etc. So you have the integral, which is uv minus the integral of v 3 over 2 du, which is the integral of x plus 1 dx. Okay, which is 2x x plus 1 raised to 3 over 2 which is x plus 1 to the power 3 over 2. X plus 1 to the 3 over 2. And then here you add 1, which is 5 over 2. Like this. We have this one. Which is the area of this. Which is 2 into 2x over 3. Which is 5 over 2. Ah, 0. Minus 1 to 0, please. This one. Okay. Like so. So the area okay. 2 into x into 2 into 2x over 3. Jumped one screen. So area is 2 into 2x over 3 3 over 2 minus 4 over 15. So now which is x plus 1, 5 over 2. Write the area. Okay, so you put a 1 there. So you have minus 1 plus 1 to the power 3 over 2 minus 4 over 15 Okay, the area. Goodness me, this one here. Okay, minus 1 plus 1 and minus 1 plus 1, this will all be 0. So you have 1 plus 1 here, which is 2. And this one is 2 by 2, which is 4 out of 3. Okay, 4 out of 3, and then this one is 2 to the power 2 to the power 5 out of 2. area. So we use 2 to the power 3. 2 to the power 3 is 8. And then what is the square root of 8? It's 2 to the square root of 2. So if it's 2 to the square root of 2 here by 4, so it's 8 to the square root of 2 out of 3 minus. This one is 2 to the power 5, which is 32. What is the square root of 32? It's 4 to the square root of 2 by 4, 16 to the square root of 2. 15 is the base. 15 divided by 3 is what? Is 5. 15 divided by 3 is 5. 5 by 8 is what? Is 40. Anyway, yeah. The square root of 2. Then what is 40 minus 16? 24. Okay. So let's remove this one. Area. Right. Okay, let's just check. Yeah, so it's 24 the square root of 2 out of 15. I'll just check if this is no mistake. 24 the square root of 2 out of 15. And then you have here. Okay. 3 divide by 3. Right, you have 5. Divide by 3, you have 8. The square root of 2. Anyway, I think it is a small typo. Just 1 minute. Ah, it is a small typo. Okay, it's -1 to 0. -1 to 0. And then the typo is that I put a 1 here. Must be 0. -1 to 0. So I put the 1 that was there earlier. Okay, so I'm just rectifying that. Just a sec. Right, I'm just rectifying that. So this one is going to be 0. Okay. So it's 0, 0. Okay. And then this one is okay. So no. See, the things are just switched around here. Okay, let me just remove all this. Right, let me just remove all this because now we just a typo in the limits. Right, and then now it has created a bit of unnecessary work. Okay, so I'm trying to clean up yeah, apologies there because it's -1 to 0. Okay, obviously the question was from -1 to 1, but that was a typo in the question because it is the textbook focused on -1 to 0, which is what we're gonna do. So you have 2. So you plug in 0 first. So it's gonna be 2 by 0 out of 3. 0 plus 1 out of 3 over 2. 4 out of 15. 0 plus 1, 5 out of 2. Minus. Then you plug in the -1, which is 2 into -1. -1 plus 1, 3 over 2. Minus 4 out of 15. -1 plus 1, 5 over 2. So, okay, that's okay. It's just, let me just let's just do multiplication here, distribution. Let's just do some distribution. Right, so we're gonna have here with us, this is gonna be 0. 2 by 0 is 0, so this one is 1 here, the 1 to the power 5 out of 2. By 4 is minus 8 out of 15. Right, so if you have this and this will be 0. So it's just 8 out of 15. Okay. Negative area. And there's nothing you can do, just negative area. So which means that you're gonna say, okay, in a case like this, you're gonna say hence area is the modulus of minus 8 on 15, which is 8 on 15 units squared. And this is the area required. This is exactly the area that is what? That is required there. Okay, because you'd have seen that at this point, what we have is that we have found the area and we multiplied the area by 2, but we started by finding the area of the upper half of the region. And then when we found the area of the upper half of the region, this one, we just multiplied it by 2. Similarly, somebody would have done this differently. So obviously you can see the effect of that. It's making things negative, it's making the area negative, meaning you need to multiply it by you need to take the absolute value of the area. So it's something that obviously you need to consider. Let's do more area problems. Let's do more area problems. Next question. Okay, let me remove this one. Right, is what we had earlier, but I soon realized that, okay, it was to be removed. Okay, now another example. An example. Number 1. Okay, here's the example. Okay, anyhow, let me just put one question. Just make it one example, and then if we finish it, then we shall do another one. Okay, find the area right, find the area included between the line. Oops. Right, find the area included between the line y equals 3x plus 4 in the curve. Y equals x squared. Solution. Find the area included find the area included between the line y equals this and the curve that. Okay, a sketch. Right, so in this sketch, what do you have here? You have y and x. And then now if x is 0, y is 4. And then now, okay. And then now this one here is going to be minus 4/3 when x is 0. Okay, so what are the points of intersection? Okay. Points of intersection. Okay, we continue, please. Right, so we're looking at y equals x squared together with y equals 3x plus 4, which means x squared is 3x plus 4. So, oops. So what are the factors here? The linear factors of x squared are x and x. Minus 4 and 1. X is 4 or x is minus 1. Okay. Okay, using the quadratic, for instance, if x is 4 here, 4 squared is 16. If x is minus 1 here and you square it, you get a 1. X is that are points of intersection. Okay, where are we? We are here, okay? So we got the points of intersection there. And now 4, 16 minus 1, 1. Minus 1, 1. And then 4, 16. So minus 1 to 4. Which is 3x plus 4. minus x squared dx. Okay, the upper curve is a straight line, the lower curve is the parabola. So we're interested in the area. Just find the area. Right, so it's going to be 3x squared out of 2 plus 4x x cubed out of 3. All right, like so, from -1 to 4, just like that. So what is the answer? The area? Put 4 is 3 out of 2, 4 squared. Plus 4 into -1 minus that cubed. Okay. So the answer here is 125. 20 and 5 out of 6 units squared. Another example. Another example. Find the area. Included between the curve y equals, okay, sorry, y equals sine squared. Let's look at y equals sine squared. Okay. Right, so if you look at the curve y equals the sine squared, just a sec. Right, so we're looking at that particular curve here, y equals this sine squared of x together with the x-axis and the lines. X equal to 0 and okay, let's look at the solution to this together. Solution. Right, so we need to find here with us or in front of us the area included by the curve y equals the trigonometric sine squared of x. So how do we solve this simple question? We proceed as follows. So we have y equals the sine squared of x. Okay, so this one can be done in two ways between x equals 0 and x equals pi over 2. So okay, then we have this, okay, sheet. Okay, this is another graph that has symmetry at x equals pi over 2. Okay, so between 0 and x equals pi over 2 is the area we want. But we understand that it's going to reach the top here, but the top that it's going to reach is at 1. It's going to reach that at 1. Okay, because when x is pi over 2, like 90 degrees, this is like 90 degrees in radians. So the sine of 90 is 1. So it's going to have a maximum there. Okay, this is the graph of the sine squared of x. Okay, to see the graph, they said it's best to use point by point plotting. Point, plot the points, etc., and be able to trace the curve. But now then, it's easier to start this from bottom up, meaning we're going to integrate it from 0 to pi over 2. So the area. We integrate from 0 to pi over 2 on the x-axis. Then the upper curve is clearly the sine squared minus the lower curve. Area. Which is 1/2. 1 plus cosine 2x. Which is x plus 2x out of 2 from 0 to pi over 2. Which is pi over 2. Okay, so right, so in the end, the sine 0 and the 2 cancels, given of pi is a semi-distance of 180 degrees 0, and then the answer becomes 4. So which means, therefore, the area here is actually pi out of 4 square units. Okay, so that becomes the answer. Okay. Let's look at another example. Right, another example. Right, in this example, we're saying find the area included. Okay, let's find the area included. Right, we're finding the area included. Right. Right, between. Find the area included between the two curves. And x squared is 4y. Solution. So find the area included between the two curves, this one and that one. Okay, we need to just have a rough idea of the sketch. How does the area here look like? How does the area here look like? Okay, so very easy. Y-axis and x-axis. Okay, the graph of this one is like the graph of 1/4 x squared. So you can look at it as the grade 10 kind of graph. So is 1/4 x squared. So we know the shape is like this. Okay, otherwise one can use point by point plotting and use a table and take many points and connect the dots or the points. And then now this one is not popular, at least in the South African school curriculum, except for those who are doing AP math, because it is a parabola as well, but it's a parabola that is of the form now. So you have y squared out of 4 equals x. So here we're talking about non-negative x. So it's a parabola that is like this. And its equation is x equals y squared out of 4. Okay, so it's the area between the curves. So now, how do we then find this? So we must find the point of intersection or points of intersection. Right, the points of intersection are going to occur at a couple of points. If you have y squared over 4, which is x, and y is a quarter x squared. Okay, on the upper part, we have y equals 2 the square root of x, which means here. Okay, so this obviously brings that, so that if you substitute this one there, In the place of y, you put 2 the square root of x. Which is 4x. Okay, 64. Right, so here you have 64x. Okay, just here, 64x equals x to the 4th power. All right, if x to the 4th power equals 64, x. Okay, you pull out x. Right, which means x cubed is 64. And if you take the cube root of 64, it's exactly 4. So meaning they intersect at this point, but the points of intersection go on with the functions themselves. Like you have y equals a quarter x squared, which means 0 or 4. 0, 0, 4, 4. Okay. So the area. So integrate from 0 to 4. Okay, so okay, continue, please. Which one is the upper curve here? Which one is the lower curve? So the upper curve is this one, which is exactly the same as 2 to the square of x, this. Which is 2 the square of x minus 1 quarter x squared. Area. X to the 3 over 2. Okay, so you add 1 and you divide by 1 half plus 1. So here is 1 quarter, and you have x cubed, you divide by 3 as well. You integrate from 0 to 4, like so. Okay, let's check. What answer are we getting here? Area. So this is like 4 out of 3. 4, you cube it like this. Oh my goodness. So what is the answer? This is like 2 squared. 4 is 2 squared. So 2 squared is going to cancel, giving us 2 cubed. 64 out of 12. And this is 8 by 4. 32 out of 3 minus 64 out of 12. Well, by the looks of things is exactly 5 and 1/3 units cubed. Unit squared area. Here is an exercise. Here is an exercise. Home activity. Just one, not many. Right, so the home activity is this one. Right, just putting it now here on the screen. Prove that. The area enclosed by the straight line. Y equals 3 and the curve. -7.5 minus 4. Prove that the area enclosed by the straight line y equals 3 and the curve, this one here is this. Maybe I can give 2 of them. Last one. Just the last exercise. Find the area. Bounded by the curve. Y equals in x. The x-axis. And the line. Find the area bounded by the curve y equals in x, the x-axis, and the lines, this and that. Okay. So these are the 2 home activities. So please try them. In our next discussion, we can discuss them. And then we can look at the next area of interest, the next chapter of interest. Yeah, but I must thank you for joining us. I'm sure this is enough for today. If needs be, or if need be, yeah, we can meet again tomorrow. Okay, because I can assume that today maybe it's enough. You're exhausted. If today you are very energetic, you can meet again later on in the evening, something like that, when you have rested. But I mean, all that depends on you. But I'm sure that it's enough for today. We've covered like 2 hours on average, so it's enough. I'm going to upload the video in the next couple of minutes. I'm going to send you the link to the video so that you can just watch the video and take note of the things that are actually that we discussed here. Right, any questions or any suggestions, anything? Nothing.
Hi, sorry, can you hear me? Sorry, yes, I was speaking on that. Yeah, thank you so much. We can, I'll let you know.
Okay, that's fine. So I'll hear from you then. Okay.
Thank you so much. Enjoy your day.
Okay, thanks a lot. We keep in touch. I'll keep you posted. I'll send a video link in the next couple of minutes. Thank you, and we'll talk, and
Okay.
goodbye.
Thank you.
Goodbye.
Bye-bye.
Goodbye.